Hello class, today we're going to talk about angles and lines and intersections and stuff like that. But to start with, we're going to talk about parallel lines, skew lines, and parallel planes, stuff that don't ever intersect. Parallel lines, as everybody knows, these are lines that go the same direction. They never intersect. This is like line M and line N. We show that these are parallel with these little arrows here. Very important about parallel lines is that they are on the same plane. They are coplanar. All right? Skew lines are lines that don't intersect, and they are not on the same plane, non-coplanar. That would be like line M and line K. As you see, they're not going to intersect because they're on different planes, but they are not parallel. They don't go the same direction. All right. And last, we have parallel planes. Those are planes that never intersect. Okay. Now, to show that two lines are parallel, we use these arrows here. In most textbooks, they'll be red, but on your papers and stuff, they'll be black because you've just got a pencil. And we write it like this. Line M is parallel to line N. These two lines here means parallel. And we can say the same thing with planes. Plane T is parallel to plane U. Now, there is a plane here that contains line N and line K. It is not shown. Just know that it does exist. Any two lines that are not skew are going to be coplanar. Right? Just not always shown. So let's take a look at this. I would like you to pause the video, answer these 4 questions. Note that all of these does want to contain the point A. So if you pause the video. And now you're back. So here we go. We're going to look at each of these lines as segments as though they were a line, because a line contains this segment AB. We just don't draw the whole line. And so put A, line parallel to line CD containing point A, and that would be right here at line AB or line BA. Either one of those is good. HG is also parallel, but it does not contain the point A. Lines skewed to CD containing point A. So these are lines that will never intersect line CD, but they are not parallel, and there are more than one of those. We have these. Line AH, line AG. Not line AB because it's parallel. Now, depending on the professor, he also could say line AE, which would be right here. Oops, if I have a pen. Line AE, and that's an awful line, but there it is, line AE, or even line AF coming up the diagonal across the entire thing there. All right. But it's not drawn, and so there it is. But they do exist. All right, we need line perpendicular to CD containing point A, and that would be line AD right here. BC and DE are also perpendicular, but they do not contain the point A. And last, planes parallel to EFG containing point A, and that would be, let's see, EFG is the one on the bottom, and parallel to that would be the plane on the top, plane ABC, or if you called it CDB, whichever. So here we have 2 postulates, the parallel postulate and the perpendicular postulate. Both say basically the same thing, just with different kinds of lines. So a parallel postulate, what that says is that if you have a line and a point that's not on the line, there is one and only one line through this point parallel to the first line. This red line is the only possible line through point P parallel to line L. That's it. Perpendicular postulate says basically the same thing, only it says that there's only one line perpendicular to line L that goes through point P. This is the one and only one. There can only be one. All right. That's what it says. So let's take a look at this. Alrighty, we need to name a pair of parallel lines. We need to name a pair of perpendicular lines, and we want to know, is segment FE parallel to segment AC? I would like for you to pause the video, answer these 3 questions, and then come back. Alright, so here we go. Name a pair of parallel lines. Hopefully, let's see. Line MD and line EF. Those are parallel because they've got these little tick marks, these little arrows. A lot of you probably said line EC and line BF. But do those have the little arrows on them? No, they don't. So these are not parallel as far as we can tell. It has to have the little arrow saying that it's parallel, or you can't say they're parallel. Okay, perpendicular lines. That would be line DM parallel to line BF. Again, we could not say that DM is or EF is perpendicular to line CE because it is not marked with the little right angle mark. And is FE parallel to AC? No. We have already said that FE is parallel to DM, and there can only be one line through point M parallel to line FE, and it's DM, not AC. Okay, so here we have some definitions. This line right here, this is called a transversal, line T. A transversal, all that means is you have a line that goes across two other lines. That's it. Trans means across, the versals is lines. Alright, so what we have here, we have a line drawn across two other lines, and as you see, that makes 8 different angles. And those 8 different angles have 5 different relationships that we can talk about. Okay, corresponding angles in the same place on the separate intersections. That's very, very important. All of these relationships here, all 5 of them, you have to have one angle on the both of the intersections. Okay, if both angles are on one intersection, they're not these. All right, you have to have one angle on one intersection and one angle on the other intersection. Okay, so first we have corresponding angles. Corresponding angles are in the same position for their intersection. So for example, 2 and 6 are both in the top right. Right? So they are corresponding because they're both in the same position. Next we have alternate interior angles. Alternate interior angles, the alternate refers to both on different sides of the transversal. Right, we have 4 over here and 5 over there. Interior is saying, is it between the 2 lines that got crossed? Right? And so 4 and 5 are in between these 2 lines. They are on the inside. Right? Next, alternate exterior, on different sides of the transversal, and they are outside the 2 lines that got crossed. So 1 is up above and 8 is down below. They are not in the middle, they are on the outside, exterior. Consecutive interior angles, you may also see this referred to as same side interior angles. These are on the same side of the transversal, and they are on the interior of the angle, of the 2 lines that got crossed. So we have 3 and 5, they are on the same side of line T, and they are in between the other 2 lines. So they are on the interior. And lastly, we have the same side exterior angles. Again, same side of the transversal, but now they are exterior, meaning they are outside the 2 lines that got crossed. Right? And that's just ways we can refer to these angles. And we're going to have some theorems about them later on. So what I want you to do is to pause the video again and name all of the angles that fit these different types. Okay, so let's see, we are back, and we want to make those all go away. There we go. So let's see if we got them right. Corresponding, 1 and 5, 2 and 6, 3 and 7, 4 and 8. Again, all of these are in the same position as their partner. Alternate interior angles, so that would be 2 and 7, across the transversal here, inside. 4 and 5, same thing, inside the 2 lines. Alternate exterior, we have 1 and 8, crossing the transversal on the outside of the 2 lines, and 3 and 6, same thing. Consecutive interior, 2 and 5, and 4 and 7. They're on the same side of the transversal, and they also interior, they're between the 2 lines that are crossed. And same side exterior would be 1 and 6, and 3 and 8. They are on the same side of the transversal, and they are on the outside of the lines that got crossed. And that is it. So Very simple lesson. Just you got to keep track of these 5 angle relationships. They're very, very important, and they'll be used in 70% of the proofs used in geometry from this point on. All right? So you've got to learn these 5 angle relationships. Hopefully this helped, and I will see you next time.